you think? So it's kind of interesting to think about. I was 4 years old when this happened, and so obviously I don't remember it. My older sister, who's here, says she remembers it. But it's amazing the power of that journey, and to think that we've been to the moon. But it's sacrilege if you're a movie buff, but we're going to cut the credits and just hopefully bring up the slide. One of the questions that I get asked, and again, I'm Mark Moldwin. I'm a professor of climate and space science and engineering here at the University of Michigan, and also the executive director of NASA's Michigan Space Grant Consortium. And one of the questions I get a lot, I teach a rocket science 101 class and a space environment class, is why haven't we been back to the moon? It's kind of weird. You would think when you're growing up, we were going to have Jetson type of autonomous vehicles and robots and all types of things, and not a lot has changed from the 1960s. The cars look the same, the houses, the airplanes, everything look the same. What's happened? But it will be short to give you a lot of time for questions, and I put this slide in here just as an advertisement, particularly if you're a student, undergraduate or graduate student, or a researcher. One of the nice things about this job with NASA is that NASA has 52 state space grants, all 50 states plus Washington, D.C. and Puerto Rico. And we're part of NASA's Office of STEM Engagement, and we're in charge of developing the education and public outreach programs for NASA, and they're distributed in each state. We consist of 11 universities here in the state, and we support students and nonprofit education organizations, as well as teachers throughout the state. So if you're interested in getting excited about NASA, we can help you. And the reason why this movie is here is obviously next July is the 50th anniversary of the moon landing. It was, an incredible achievement, not only personally for the astronauts, but the thousands and thousands of scientists and engineers and support staff that obviously were behind it. We've had a lot of movies lately celebrating a number of these people, from Hidden Figures, thinking about the orbital dynamics, all the way up to wondering about planetary protection and do they need to be in quarantine. So a huge amount of research and effort. And when you think about this achievement, it's not only personal for Neil Armstrong, but it's also technological and societal and a real human achievement. If anybody's read reviews of the movie, there has been some political controversy about this, which seems strange. It really is a human achievement, but also a national, an American achievement. And I was glad to see that they actually had the flag on the moon. So I don't know what they're talking about. But one of the things that we've been doing, if you were in college now, essentially you've been alive, that there's somebody been off Earth in orbit of Earth every day of your life. We've essentially had the Space Shuttle and International Space Stations and their predecessors for many, many years. And the question is, why can we only go up to low Earth orbit, which is only a few hundred miles above the surface? The moon is, if you can visualize the Earth, one of the standard units we use is an Earth radii, so half the diameter of the Earth. The moon is 60 Earth radii away from us. So if you're going to make a scale model of the Earth and the moon, which like they drew on the blackboard, if you put like a marble as the Earth, you'd have to go 30 of them away for the moon. And so it is a really long way. It took them many, many days going at many tens of thousands of miles per hour to get there. And so it's an unbelievable achievement, and particularly considering we've only been going a few hundred miles above the surface. So the question is, why haven't we gone there? And for many administrations, including the most recent Trump administration, they have given NASA a strategic plan to go back to the moon as a stepping stone to Mars. There has been debate lately on if we're going to go directly to Mars or if we should go back to the moon, similar to Neil Armstrong's ideas. We need to have the Mercury, and then the Gemini, and then the Apollo. And why was it Apollo 11 and not Apollo 1, 2, 3, 4, 5? Right? You have to be testing and testing and testing. And a lot of these things we don't know about, and so we have to try it. And so that's part of the yin and yang of NASA. It's failure's not an option, but if failure's not an option, you'll never try anything new. And so you have to always fight this fear of failure to be innovative. And so a number of folks earlier this year, Trump sent NASA instructions to go back to the moon and Mars. But one of the reasons, and if you've been reading the news the last week, a lot of things have happened. We have astronauts on an International Space Station right now. The United States does not have the ability to send astronauts to the International Space Station, so we contract out with Russia. And one of their Soyuz rockets had a catastrophic failure. The first stage, when it separated, ran into the second stage, caused an explosion. They were able to abort, and they crash-landed many hundred miles away from their takeoff. Fortunately, the American and the Russian cosmonaut landed safely, but it has put a big crimp into our plan. So even today, 50 years after the Apollo successful landing, we have difficulty to get people into low Earth orbit, let alone all the way to the moon. So here's some headlines from last week. The first one about this harrowing escape. It could have been a lot worse. When you think about the early missions, if you have a catastrophic failure at the second stage, it's not a lot you can do. And so it is quite amazing that the engineering allowed them to do that. The big rocket, similar to the Saturn rocket that right now is called the SLS, the Space Launch System. So these are, Statue of Liberty size rockets that would be able to lift tons and tons of material up into space. And if we had the SLS, we'd be able to send astronauts back to the moon. But the internal audit of NASA showed that it's over budget and behind schedule. Essentially, it's spent all of its budget 3 years before it was supposed to end, and it hasn't delivered any major component. And so they have to go back to Congress and ask for additional billions of dollars to continue this testing. And then, on top of that, one of the plans to get people up was the SLS, and now with the Soyuz failure, the safety board is questioning a lot of the NASA's plans to return to orbit. So the big news in space most recently is sort of the commercial access to space besides NASA. NASA has developed this program called the Commercial Crew. They had a competition to see who could build a capsule and a rocket, and it came down to two companies, Boeing and SpaceX, and because of politics, both won. And so our commercial crew essentially selected both options from Boeing and SpaceX. And so the good news is if you want to be an astronaut, you don't only have to be a NASA astronaut, because Boeing is going to send their own astronauts, and SpaceX are going to send their own astronauts, and they're going to have their own crew capsules and their own Boeing and SpaceX space suits. So we're going to have a lot of opportunities to potentially go up into space. But of course, anytime you have a human on board, the reviews are really catastrophic. The Werner von Braun, father of the Apollo and the Saturn V, he claimed that the gravity is nothing. The hard part of getting into orbit is the paperwork. So these new ideas, the Starliner from Boeing and SpaceX with their BFR, Big Falcon rocket, and their capsule are going to be able to launch people into space. But again, every failure, one of the first things you want to do is learn from your failure, or you don't want to repeat your mistakes. And so we'll see on the future of these two capsules. So we have NASA's plans, and a number of presidents, from President Bush to Obama to Trump, have directed NASA to go back to the moon or to Mars or to an asteroid or to develop other manned missions. If you Google NASA and Mars, you would go to a web page that describes all about Mars exploration. Of course, the plans like this movie and The Martian, which is another good, fun movie, tries to talk to this yearning of space exploration and having a vantage point that we haven't had before. But despite the plans and the unbelievable talent that we have, not only in the state of Michigan, but in the world in terms of engineering and science, research and development, there are major technological hurdles, both with the rocket, the crew capsule, the orbital dynamics, the biological issues. If you follow any of the biologies of human in space, we like living on the surface of the Earth. We don't like low gravity. Our muscles and bones weaken. We don't like the radiation environment. And so one of the plans for the commercial launches to Mars is essentially one-way trips. And it's not that we can't get them there and back, but the lethal doses of radiation are anticipated. And so they might need to read a letter intentionally, because they're going to be the first explorers on Mars, might never come back. But besides those technological and biological, very huge financial costs, NASA's budget this year is about $19 billion, which sounds like a lot of money, but it's essentially been flat since 2001. But any rocket generally costs a few $100 million just for the rocket, and a kilogram of payload to get to the moon is about $40,000 to $50,000. So if you think of a water bottle, that's a 1 liter bottle, that's a kilogram. It's $50,000 to bring that water bottle with you to the moon. So it's very expensive, and it's because of the thousands of people needed to do all the designs and testing. So if you Google NASA's plans to go back to the moon and look at the strategic directions, you can see dates from SpaceX, from Boeing and NASA, and they range from the 2020s to the mid-2030s to NLE, no earlier than, or no earlier than, NET, than the 2040s, which seems really far away. We want our Jetsons and our space colonies. So why we haven't gone? It's really expensive, it's really hard, and even though we've been doing this now for my entire life, there are still many technological and biological hurdles that we don't understand to overcome traveling into space. The moon is one thing, going to Mars is another. And so I hope you got excited about the first man and left some time for some questions. And there are some microphones here, or if you have a big voice, I can repeat it.
We would like to welcome you guys to come down to one of the microphones and ask some questions if you have them. So please take a moment, step up, and we'll just kind of go one at a time, alternating, probably mic to mic. You can start.
Okay, thank you for presenting. I'm not deeply committed to staying abreast of developments on the space program, unlike many of the people here. But I'm curious, what can you tell me Was it a pair of twins where one of them went out for a very long time and they were able to take biological difference measurements when he came back? Long term, what do we know aside from the immediate that might have been discerned from that study?
Yeah, Commander Kelly, he's famous not only for being an astronaut and a twin who stayed down, he's also the husband of Congresswoman Gifford from Arizona. But there's a number of effects from weightlessness, obviously, but also radiation. Most astronauts that have spent considerable time, many months on the International Space Station, as they've aged, since we've now had decades of experience, they've developed cataracts. Many astronauts develop vision issues, even on board, and that don't get corrected. That's not thought to be radiation, but thought to be some type of issue with fluid in the eye. So there's a lot of research in ophthalmology. We know because of the radiation, astronauts are considered radiation workers by OSHA, the Occupational Safety Health Administration, and they have dose limits for how much exposure. And an orbit or a day on the ISS is equivalent to about 10 chest x-rays worth of radiation. And so it's a very high radiation environment. So that's the big issue when you start thinking about to go to Mars would be at least a 3-year mission. And so it's just, we don't like it, all that radiation.
I found a moment in the film I found really interesting was when they showed Kurt Vonnegut and all the protesters there arguing that it was too much money, it wasn't worth us to go to the moon. And that's an argument that I see today often. I'm wondering what you think the greatest benefits of us going to the moon, what they were.
Yeah, what's interesting from today and even back in the 1960s, if you think about what was going on in 1968 from the Vietnam War, the Civil Rights Movement, the MLK, the Robbie Kennedy, I mean, there's so much was going on at the time that when the landing happened, hundreds of millions of people from around the world stopped, right? And this was before TVs everywhere, right? And so you had to go to the city square to watch this. It was such a, we've been looking at the moon for so long and wondering what's up there and the questions to the, where did we come from? What's the origin and evolution of Earth, the origin and evolution of life? Are we alone? And we still have those questions. And so a lot of the work that we're doing now is we're discovering exoplanets. So just in the last 10 years, we've discovered planets around other stars. And just in the last few years with Kepler, we've discovered that pretty much every star you can see out tonight has a solar system. And not only does it have a solar system, it has Earth-size planets. And so let's go, right? We've discovered Alpha Centauri, our nearest star system, has a solar system. It's 4 light years away. Let's go, right? We still have this drive as explorers, trying to understand our place in the universe. But obviously that doesn't pay the bills. And so when you think about our communication technologies in terms of GPS in your phone to your cell phone itself and all the sensors, those were driven a lot by the ability to communicate. And if you think about climate change as being one of the major concerns of humanity today, having the vantage point from a few hundred miles looking down to observe the Earth globally is important. And going back to Apollo, the first, Apollo 8 picture of the Earth as a single sphere, at Earth Day, and just thinking about the Earth as this little blue dot in the dark sky, and all of life in the universe that we know about is just on that little dot.
Hi, I was in my early 20s when most of this happened, so I remember it very well. In fact, I met Ed White and Jim McDivitt when they were here in Ann Arbor.
Great.
After their Gemini, I brought them a couple of newspapers. That's how I got into to see them. They were staying at the university's Ingalls House. Two things. One is the reason we're not going to the moon now is because Russia or China isn't doing it, because the competition seemed to be a big factor in funding it. And the other question is, a big deal is made about SpaceX or Boeing, but McDonald's built the Mercury and Gemini capsules. The Boeing, I think, built the Apollo one. So we've always had private industries, aircraft industries, building these things. So what's the difference today?
Yeah, so one of the cool things about the University of Michigan is not only do we have a lot of famous alumni that were astronauts, and if you know the names of the astronauts watching this movie, when they first introduced them, you knew what was going to be happening to Gus Grissom, but you were still on the edge of your feet, or on your seat, right? So the director did great. So, but China has announced plans to develop not only their own space station, and they have it, but they've also been landing orbiters on the moon. So they've been doing a lot of lunar science. So they have their first taikonauts. So now not only does the US, Russia, but now China has the capability of launching their own astronauts, or the US used to have their own capabilities and hoped soon. So there still is competition, and if you've been reading the news, there's a lot of gnashing on teeth in terms of technological superiority with China. And there is actual law that says that NASA, including myself, NASA funded, I am not able to do any collaborations with Chinese scientists on spaceflight hardware. But if you've ever gone to Kennedy Space Center, they have a Saturn V exhibit, and you can walk along the whole rocket. And the thing that's so surprising is every part was built by a different McDonald's, Douglas, Chrysler, Boeing, right? I mean, and it worked, which was amazing, all this integration. So the commercial sector has supported quite a bit. And there's about 700 companies in the state of Michigan that are members of the Michigan Aerospace Manufacturers Association. Who knew that we have such a huge, but it's part of the automotive, also aerospace. But what's new with the commercial crew is that NASA is giving a check for them to develop on their own the capability to get people to the International Space Station. And so they have control over the astronaut selection and the delivery schedule. So the new part is it's truly commercial. It's not that NASA contracts out with somebody to buy components that are integrated into a NASA mission. It's Boeing working underneath this commercial crew agreement that will launch Boeing astronauts.
Thank you.
About 2 years ago, the New York Times had an article about cultures around the world with the understanding that we could send astronauts to Mars but couldn't bring them back, so they'd have to live there. And the Dutch were all for it. They would volunteer for such a trip, never to return. And then quickly, how much legroom would there be on the Boeing capsule?
Yeah, I was not at the meeting, and it was many, many years ago, probably over a decade, at a Lunar Planetary Institute meeting, talking about going to Mars, asking a group of scientists, how many of you would volunteer for a one-way trip? And surprised, a lot of people raised their hand. And sort of thinking, when you're looking at Neil Armstrong, did he realize the heroic journey he's on? And kids today, 50 years, they only know one astronaut, Neil Armstrong, right? I mean, so he will live forever as the first human to step on the moon.
Buzz is pretty famous, too.
Yeah, Buzz is famous, but you should challenge students, name a living or a astronaut. But there are a number of commercial ideas. Elon Musk wants to have a city on Mars, and he's planning to have close to 1 million people by 2035 on Mars. There's a thing called Mars One, where they've asked for volunteers, and they've down-selected to 100 astronauts, and all of them have agreed for a one-way trip. So there are people who are interested in that adventure and exploration. And so when you think of the polar explorers just at the turn of the last century, right? They were not necessarily expecting to come back. So it's interesting what humans can do.
About the lunar surface, I noticed in the movie that the movie Armstrong took a long time to get off the pad of the LEM onto the lunar surface. And I wonder if there was any fear that once he stepped on the surface that he would keep sinking and sinking. And related to that, I've heard that moon dust is very messy and irritating. And I wonder if that would present a problem if we decided to go back to the moon and stay in it for any length of time.
Yeah, the lunar regolith, or the lunar dirt, has essentially been there for billions of years, and it's being constantly bombarded. There's a citizen science program that essentially started to take video of the moon constantly. So all around the world, whenever the moon is visible, they have videos. And we now can actually see flashes on the moon, and we can estimate how much energy must be released to actually see it on a video cam from Earth. And so we know that meter-sized craters are being generated constantly. So it's being bombarded, and it's been doing that for billions of years. And so the surface is this very fine talcum powder type of regolith that can get very irritating. It's mostly silicates, it's mostly lava flows, and so it can be sharp-grained. Tommy Gold, a very famous geophysicist, astrobiologist, curmudgeon, he once gave a talk at where I was at school, and he was at Cornell, and he asked if he could arrange his own transportation, and they said, sure, just give us the bill, and he got a helicopter and flew and wiped out the department's travel budget. But he thought, and he did the estimates that if you land on the moon, you're going to sink right in. It's talcum powder, right? You'll go in. And so NASA actually created the Ranger program to actually land things on the moon to see what the surface is. So before Neil stepped, we had landed on it. And part of the reasons for the pad, they actually had depth, so he could actually say, I sunk in a certain amount as part of the first experiment. But everything's new, right? They had no idea, and until you try it, you're not always trusting everything.
I have another question. After watching this movie, could you tell us one moment in it that you thought was pure Hollywood, and one point in the story that you wish would have been in the movie?
Yeah, I was not familiar with Neil Armstrong's personal story and the tragedies of his life. And it's like after the first few minutes of the movie, I go, yeah, that makes me want to be a test pilot. Yeah. And so that was very interesting just on the personal aspects, having to work in a profession where you're attending funerals of your colleagues. It's sort of truly military, why most of the folks were military test pilots before going on. But in terms of, in the back of my mind when they were landing and there was this big chasm in front, I don't know. I always thought they landed on the Sea of Tranquility because there was nothing there. So I don't know how realistic that was. I have to go back and check to see if there were cliffs right near the landing pad. But the other sense of it was sort of that sense of questioning that was throughout the movie. Whitey's on the moon and I can't afford to eat. And we have that debate right now. The NASA budget is in the same budget for Health and Human Services and HUD, right? And so when you go, do you really want to spend $400 million for the next Mars rover, or do you want to? And so when you put them in those types of choices, it seems like it's clear cut. There are huge needs here. I'd rather Kurt Vonnegut's. I'd rather have a safe New York than people on the moon. But when you step back a little bit and not make it sort of that false dichotomy, thinking about who we are as humans in terms of we want to know who we are, where we came from, are we alone? And what's really cool about today is we can start answering some of these questions. You know, we wanted to know, are there other planets out there? Yes, there are. Are there other Earth-like planets? Yes, there are. Do they have atmospheres? Do they have water? Do they have life? You know, so until we develop that next propulsion system to go to Alpha Centauri, we're not going to do it. Carl Sagan wrote a book called Pale Blue Dot. If you haven't read it, it's a really good one. But the thesis of that one was, as soon as humans realize that life on Earth will end, by definition, when at the farthest when our star goes red giant. But there's a lot of other resource constraints and evolutionary, there was a beginning and there's an end. And as soon as we figured that out as a human species, we were thinking about, well, how do we prolong that? And so as explorers wanting to know what's across the Alps, what's across the Mediterranean, what's across the ocean, we want to know what's across the void. And so will we continue to do that? And so it's a true Ulysses journey that has been with us as humans. So I think stepping back and not thinking of it as a bread or a cell phone, it's more of technology and humanity is interwoven. Great. Well, thank you very much for staying.